Determine f composition f inverse of x and f inverse composition f of x for the class example 2a where we had this function. What do you notice? I won't tell you. I don't want to spoil the surprise. We'll just do this and see what we get. So our original function was 2x minus 3. The inverse happens when we swap x and y, so we get x equals 2y minus 3, which becomes 2y equals x plus 3, which becomes y equals x plus 3 over 2. So here is our original function. Actually, I'll rewrite that. I'll put it as our original function is 2x minus 3. And now that I've done the x and y swap, I can change this inverse back and say f inverse of x is x plus 3 over 2. And what they're asking us to do now is plug these two functions into one another. First in this order and then in this other order, and see what happens. So if we do f composition f inverse, that means take function f, which is 2 times something minus 3, and into it they want us to plug the inverse function, which is x plus 3 over 2. The other thing they want is start with the inverse function, which is something plus 3 over 2. And this time, this isn't just an x. They want us to put the entire function f inside it, meaning 2x minus 3. Clear as mud? This top one is take function f and sub in the inverse where x used to be. This bottom version is take the inverse, but plug in the original function where x used to be. So let's see what these give us. The top one, these 2's cancel out, and so we get x plus 3 minus 3, which cleans up to, oh, just x. With this bottom one, we have 2x minus 3 plus 3, those cancel out, which leaves us with 2x over 2, which is x. This will happen every single time, guaranteed, that you take a function and compose it with its own inverse. The two functions cancel each other out because they are perfect opposites. If you take a number, double it, knock 3 off it, then put the 3 back on, and then cut it in half, everything that this blue function did, the red function undoes. And if you go in the opposite order, take a number, increase it by 3, cut it in half, then double it and take a 3 off it, again those operations all cancel each other out. And you just get your original number back. Whatever x was in the first place, that's what's going to get spit out when all this is over. Some other examples of this would be, well, a boring one would be if you did like x plus 5 minus 5. Adding 5 and subtracting 5 are inverses. They cancel each other out. You just get x back. A slightly more interesting example, if you do something like take x, square it, and then square root it, that will also give you plain old x back. So squares and square roots are inverse functions and they cancel each other out. So anytime you have an operation that uses a function and then its inverse, the function and the inverse essentially kill each other. Each of them undoes everything that the other one did. All that comes out at the end is the original number, totally unscathed. Everything that the first function did to it, the other one will undo.